All right, we've got part 9 knocked out on precision, so let's go ahead and come over here to our implementation plan overview and mark out these major sections. This now moves us into part 10. The idea of part 10 is to get lives and levels working. And along with that, we need to go ahead and get our game states fully fleshed out so that they are working properly, as well as levels advancing. So by the end of this section, we should have a fully playable precision game. What we're going to be missing are things like the HUD and scoring. But outside of that, we'll be able to start a game, play the game, die, we're out of lives, game over, restart the game, or play the game, hey, we saved all the cells, there's no more left to be saved, level change, start again, so now the level's a little bit more complex. So once again, a fully playable game, just minus our HUD and score. So let's go ahead and jump in here. We'll turn this off, come all the way to the top, you guys know the drill by now, and throw in a new whiteboard. So here we are with part 10. Level and lives. Alright, can we get a relatively straight line? Not really. Hey, it's worth a try. Ooh, that's awful. Okay, so what do we need to get done? Well, first of all, we're going to start out with a few fields over inside of our game class. What are these fields going to be? Well, some things that are going to allow us to track things like lives, etc. We're going to start out with some level stuff. For our level, we're going to need to basically have a field that's going to hold what level we are currently on. And so that'll simply be an int level.
And it really is just that simple. Levels are represented by a number, so we're going to hold them in an integer. That is the current level that the game is currently on.
And then we're going to create two constants that we're also going to use. Basically, the first one is going to be the base number of cells.
Right, because what we run into here is we have a case where the number of cells and enemies increases level by level. But there has to be some starting value. What do cells start out at? What do enemies start out at? And what we want to do is come up with what we're going to term the base values for these numbers. And what we'll do is we'll take that base value and multiply it against the level to get the actual value of cells or enemies. That would mean that on level 1, in this case, we would have 2 cells and 1 enemy. When we progress to level 2, we'd have 4 cells and 2 enemies.
Exactly.
So this still allows some level of configuration between how many enemies we want. If we suddenly decide that it'd be more challenging if there were 3 times as many cells, we could give a base number of cells of 3.
Now, as we have these different fields for level, we've got a few fields for lives. The first and most important is we need some sort of field to store our lives in.
Right, just with the level, we need to hold a field that contains the current number of lives remaining. And we'll simply call that lives.
And as we did a little bit of initialization here at the beginning above with the base number of cells and enemies, we're also going to do that with lives. We're going to basically set up a constant that's going to hold our starting lives.
Right. Well, we need some value that's going to be the initial number of lives when the game begins. And it would use, if it wasn't for the game being able to restart, we could almost just initialize lives. Meaning, if we set lives to 3, allowed the game to be played, lives would run out, but that would be it. We'd have no way to get back to or remember what the initial setting was.
That's right.
So we'll hold that in a constant. That way, when the game, if the game is to start over, we can look at that, get the new number of lives.
Exactly.
Begin over.
So now that's all the fields we need. Now there's going to be some properties.
Right. I'll let you jot these down, and then we'll take a look at what they are.
Well, basically, with the properties, you said when we go into a level change state, we need to calculate how many cells and how many enemies we're going to have by taking this number, multiplying it by the level.
The actual number in each case was a calculation between base num cells and level.
Right. So we're going to set up some properties that's going to take care of that calculation for us.
The nice thing about setting these up as properties is that means we could actually change the formula for determining the number of cells in a level or the number of enemies in a level and not have to worry about where this was used in code. Because that way the code that uses these properties can just say, all right, that's going to contain some number. It could be random, it could be hard-coded, it could be whatever. But that gives us the ability to easily change it. So what we're going to do is we're going to take the level cell count and level enemy count properties, and inside of those properties, inside of their get accessor, is where we'll perform the calculation that multiplies base num cells and base num enemies against level.
Right. Now after properties, it's the only properties we need, so let's go ahead and move on to our methods. We've got some gameplay methods that we need to get set up. Let's go ahead and jot methods down. So these are going to be completely new methods that we're going to add in. If you'll recall, the way we've been testing precision out right now is we've been putting everything into load graphics content. Well, we're about to strip a lot of that out with the exception of loading in our font and all of our textures. What we're going to do is we're going to create a begin game and a begin level method, and that's where we're going to store appropriate code for, well, beginning a game and beginning a level.
And really, this is each of these are just a lot of initialization and initial placement for things like cells and enemies. Begin game is going to be very simple because all it's going to do is make sure that the level is at the starting level, level 1.
Oh, yeah, it's real simple. It's just basically level equals 1.
And then we need to make sure that the lives have been reset. So lives will be set to their starting value.
Starting lives. Like Hogan said, very simple. So that is, let me go and just move all the way down. So that is our begin game method. And then the other one that we're going to set up is going to be begin level. And that's a little bit more involved, but not bad.
Right, we left begin game simple because those are the things that happen only on a full game restart or initial beginning. Now begin level is going to happen every single time between every level change. And it's going to be responsible for placing all of the cells, placing all of the enemies, creating a player, and kicking off the attacking mechanism.
So just a quick look at some of the things we're going to see. First thing is we're going to need to clear out all of our lists. So we've got our actors list and we've got our bars list. We're going to clear those lists out because we're beginning a level. We don't need those lists populated with any of the actors that were created from the previous level.
Right, all those actors have to go away. They belonged to that level. So when we begin a new level, we need to start out by clearing the list so that all of the old actors and all their positions get removed, because otherwise we would have enemies and cells would carry over level to level and remain in their same position. So what we'll do is we'll clear those out at the beginning of every new level and make a new set of enemies and cells. But we have another list too, though. As you've just jotted down there, we have the bars list. Bars are handled separately from actors, and we need those to be cleared as well. We need to remove any bars that might be on screen and start fresh.
And this is where we're going to use our cell.addCells.
Right, now that we've got the list cleared, we can now create a new cell field. So we're going to use add cells to place all the cells, and now we have the value that is going to hold the level by level number of cells. We have that level cell count property. So that is what is actually going to be driving the add cells method.
Exactly. So this is what we were talking about earlier that is going to handle the calculation that was seen up here. And so now when we need to generate the cells, we simply call upon level cell count, which is going to give us the appropriate number of cells that we need to add into the new level. And then, of course, we know all the other standard stuff that will be thrown in for add cells. Of course, as we're adding cells, now we need to turn around and add enemies. Now, notice the order in which we're doing these. This is kind of important, too. We're adding all of our cells in first. Then we're adding our enemies in. So this is really nice when you're adding all of the cells. And remember, when adding cells, what happens? Well, when we place them, we run through that loop where we make sure that we're not colliding with any other actor. And if we are, we try to reposition it if we can. Well, if we had done enemies first, then we're going to check against all of our enemies and all of the cells. But since we're doing cells first, as each cell is getting added, the only thing we're checking against is other cells. I just thought I'd point that out.
Right, that way we won't do that collision check against any enemy actors. Another thing to point out is draw order. Since we don't have any type of layer ordering in place for the calls to draw, we want to create the cells first because we want the cells to be drawn behind enemies.
That's right.
If we drew the enemies first and drew the cells afterwards, then the enemies would reside or would physically draw behind all the cells. So you'd see the enemies moving and they would move beneath the cells instead of over them.
Right. So here's that level enemy count, just like the cell count. Once again, the property, and then, all the other standard stuff that we've been using. So we'll set all that up. Now that we've got our actors list populated with all of our cells, our starting enemies, the last thing we're going to throw in there is going to be the player. Ooh, but why are we creating a new player? Well, didn't we just get finished clearing out our actors list just a second ago?
Right. Despite the fact that the player reference is a field held in the game, we have to remember that the player still is pointing at an actor, the same actor that the actor list itself is pointing at. So if we clear all the actors, then that player is now pointing at an invalid reference.
Right.
Which means after we do a clear, we need to make a new player. So of course the player goes into the actors list, but we also want to make sure we maintain that reference ourselves so that when we do collision checking, we have the player always available.
And then after we create it, we'll turn around and we'll call upon reset and send in our invincibility time,
Right, this will get the player positioned.
And flickering and invincible for a second.
And kick off the invincibility.
And then final thing that we need to do is we need to take that time until attack and initialize it to the cell attack interval so that we set up our timing system. It's fully initialized now such that update can start running through that information so that we can start attacking cells.
And I believe even this line of code is actually in load graphics content at the moment. But where it needs to go is inside of begin level. So at the start of any level, time until attack gets initialized so that we have the initial delay before cells start to be attacked.
All right, and that's everything that'll go inside of begin level. So then you guys have a really good idea of what's going on there. So once we get these gameplay methods set up, we'll need to go in and take out all of that stuff and load graphics content that we put in there because it's no longer going to be needed. In fact, that'll actually mess things up a bit. And then after we do that, the next thing is game and level can begin. We need to get all of that in place with things like handling input from our title screen, excuse me, making sure that begin game gets called and the state gets properly set over to level change instead of straight into playing, which is what we have had because now we've got level change to account for. So let me go ahead and I'm just kind of running out of space here. So to jot some of that down, let me do it here on a new screen, make it a little bit easier. Alright, so as I said, basically now we're going to continue on with game and level needs to be able to properly begin.
Really, this is going to end up all but finishing the state code. There's a little bit left in player death, but this gets us very close to having all of the states set up because with game and level can begin, that means we need to put in the level change state into action. And
That's right.
One of the first things of that is going to be changing the title. Like you were saying, change the title so it advances to level change instead of to directly to playing.
GameState.title. Basically, we now need to make that call to begin game because we need to get our lives and level initialized. And then we can just turn around and set our state so the next time through update this will be handled properly. Our state just needs to be set to level change.
Right. What's interesting to point out here is that means things like begin game are going to be kicked off as a result of a state, of input from a state, instead of from load graphics content.
Right.
That means we default to title, but the game doesn't begin until input is given.
And now, since we need to find some way to get back into a playing state, we need to add in some stuff for our game state level change.
Right, and this is where this actually gets into the part where instead of in load graphics content having everything get kicked off, instead we go from the level change state. So as soon as the level change state is advanced, then we need to do things like begin the level. And so it's only after level change that we actually get our call to clearing the cell on enemy field and creating a new one, setting up the player again, and kicking everything off.
And so we'll call on begin level, like Logan just said, and we'll take that state and set it to playing so that next time through, the playing section is going to be handled. Alright, very simple. So that's the whole game and level actually beginning, starting, and firing off, and we're now in there playing. So at this point what we can do is finish our level change screen, because remember, with the level change screen at the moment, you've just got the word num in those square brackets being shown as we're sitting there for how many enemies we're going to have in the upcoming level and how many cells we're going to have. So we can go ahead and finish that off. So I'll just say wrap up level change screen.
And all of those values are readily available now.
Yep.
And up until this point, well, most of them will probably have already been used. I think all of them will have been used at that point. It's just we'll add them to the change screen as well.
And just as a note, this is just our level number, enemy, and cells. Beautiful. All right, after that, we need to make sure that 3 very important things can happen to our player, such as player needs to be able to lose lives.
That means we need to take the lives field into account whenever the player dies. We've already got some code in the case, or whenever a player dies, because we were changing the state. But we need to make sure that lives are factored into that. And
since now the player can lose those lives, we need to make sure that the game can end when the player runs out of lives.
Right. And that'll probably be an additional check along with that. We take lives away and then see, has this exhausted all the lives yet?
Leave it to me to write a huge thing, huh? Alright, so game can end when player runs out of life, so we need to make sure that that is in place. And then, now we're in a state where we're at game over, we need to be able to restart the game.
Right, once we've hit that screen, we'll need to address the game over state itself to make sure that from that state we can get back to the main title screen, so the main title state.
So we can just say this is our game over state code. Excellent. Alright, so once that's in place, everything's going to feel done, with the exception of if you successfully make it through a level, or if all of the cells in the level die, because remember, we advance from level to level when there are no cells left that can be saved. Well, we need to have level advancing in place. So we'll go ahead and set that up.
Right, we need to have some check in place as gameplay is progressing to see if we have run out of living cells. And if we have, then we need to advance, because either all the cells can be saved, some of the cells can be saved, and some of them die, or all of them die. In each of those cases, we'll end up in a case where we run out of cells. And every time that happens, every time there's no cells remaining, the level should advance to the next level.
And by getting this code into place, we're going to find a bug that is going to need to be fixed, which is very interesting. Basically, right now we are clearing out, well, on the other page, I'm not going to go back to the other whiteboard, but we're clearing out our actors, remember? And we're clearing out our bars. Well, when we clear out our actors, that dumps all of the cells that were on the screen, but we're not taking into account our cell count property, the static property that's sitting over there, or static field that's sitting over there in cell. So we're going to need to make sure that we zero that out as well. So Logan will demonstrate the bug that's set up with a very easy sprite drawing or font drawing that's going to show you how many savable cells remain. And so we need to fix that bug up. It's actually a difficult bug to track down if you're not looking for it. It can catch you by surprise.
Right. Well, what it comes down to is we have that cell count tracking field inside of cell, and that's a completely separate field and system than the cells list itself.
That's right.
The problem is in begin level we've cleared out the cells list, but we forgot about the cell count, and so the two fell out of sync.
Exactly. So that will fix that up, and I'll just put cell count over here. And in doing that, basically what we're going to do is back in cell, so we indent this, so in cell class, we're going to create a static reset cell count.
We'll just make a simple method so we can go about resetting it, because if I remember correctly, the cell count was a read-only property, and I would rather leave it to read-only because I don't want cell count to be set to some random number or some to be changed improperly. But we do need a way of zeroing it back out after clearing the list. So if we put in a reset cell count, we can do just that. Have that reset cell count set the cell count back to 0.
And then we'll turn around, go back to the game class, and inside of our begin level method, there's an L there, we'll simply make a call to the reset cell count.
Right, that's because inside of begin level is, of course, where we do the actors list, or clearing of the actors list. So right after that, we need to reset cell count, and then the two values will be back in sync.
Yep.
So if we begin a new field of cells, everything will begin with the proper numbers.
Exactly. And that's it. This is everything we're looking to have accomplished here in Part 10, and it should have us up and running with lives and levels and complete game state in place. So with that, that is going to wrap up this video. Let's go ahead and get started with the coding process.